Hi, today we're going to talk about data representation and numbering systems. So what we're saying is we can actually take any character and we can represent it in multiple ways. We can represent it in decimal system, binary, octal, or hexadecimal. So these are the four different what we're calling numbering systems. And let's understand how these work. And then for the purpose of understanding permissions in Linux, which is going to follow, we will focus then on binary and octal because those two numbering systems relate directly to your understanding of the permissions. So let's first understand each of these four systems. The first one is decimal, which is base 10. What that means is there's 10 numbers, 0 through 9, that make up this numbering system. So any number in decimal can be represented by using a combination of numbers that can be 0 through 9. So when we don't give any name to the numbering system, when we're talking about a number on a day-to-day basis, we're actually referring to a decimal system. So when we say 200, that's a decimal system. When we say 123, we're referring to a decimal system. The second one is binary, which is base 2. That means any number in binary will only use two numbers, base 2. What are those two numbers? Zeros and ones. So a binary number will only consist of zeros and ones. Octal is base 8. That means 8 numbers, which are 0 through 7, are the only numbers that are going to be used in making up an octal number. And hexadecimal is base 16. So how do we represent 16 numbers? Well, you can only represent 0 through 9, which takes care of 10 numbers. And that leaves us with 6 more to represent. But we can't use 10, 11, 12, 13, etc. because those will use 2 characters. We need 1 character. So the letters A through F are actually used to represent those. So instead of writing 10, we're going to use A. 11 is a B. 12, C. 13 is a D, E is 14, and F is 15. Now, both octal and hexadecimal think of them as shorthand for binaries. And let's look at examples of what those mean. So the first thing we're going to talk about is understanding how the decimal numbering system is, because that's what we use all day, every day. So once we understand this, we will use the same technique to understand all the other numbering systems. So let's take a number like 3,572 in decimal. So the first step to understand this is write that out. So 3,572, kind of space out each of those digits and write it out. Next step, because this is base 10, we need to write powers of 10 on top of each of these. So it's beginning from the right. So above this rightmost digit, we're going to write 10 to the power of 0. You always begin with the power of 0. Then we keep increasing as we go left. So 10 to the power of 1, 10 to the power of 2, and the last digit on the left is 10 to the power of 3. If there was more digits here, we would keep going 10 to the power of 4 and so on. So we begin from the right and we keep increasing the power as we go to the left. So the impact of this really is that you begin with 1, because 10 to the 0 is 1. Every number to the power of 0 is 1. 10 to the 1 is 10. 10 to the power of 2 is 100, and so on. So you see that? You can just add 0 each time you go left. So 1 becomes 10 as you go left. Then 100 and 1,000. And since that's the last one, we stop here. So the only reason I've put this here is so that we understand why we're using 1, 10, 100, and 1,000. We're using it because we are raising the power of 10 because it's a base 10 number. Next step is to take this number here and multiply it with this number here. So 2 multiplied by 1, which is a 2. Similarly, 7 multiplied by 10, which is 70. 5 multiplied by 100, which is 500. And 3 multiplied by 1,000, which is 3,000. So if we then add 3,000 plus 500 plus 70 plus 2, that's how we get this final number of 3,572. It might seem obvious, but that's, if you follow this methodically, that's how we will use this technique to understand the other numbering systems. All right, so this is how any decimal system can be understood, any number in the decimal system. Let's now go to the next step, where we are going to take decimal number and see how we can convert that to a binary number. So in decimal, we would have 0 through 9 numbers. And in binary, we just have 0 and 1. So let's take a small number and see how we can convert that. 78, let's say, is the decimal number, and we need to make a binary from it. So how do we go about doing that? So there's many techniques of all of these that you may come across. We are going to focus on one technique just for simplicity. If you already know a different technique and want to use it, you're welcome to, but we will just stick to one way of doing things here. All right, so 78 decimal, how do we start converting that to binary? Well, because it's binary, you're going to use powers of 2. Just like here, it was base 10, so we use powers of 10. Binary is base 2, so we use powers of 2. And what do? We begin from the right and keep increasing the power. 2 to the 0, 2 to the 1, 2 to the 2, and so on. We keep increasing it. So what does that really mean? 2 to the 0, anything to the power of 0 is 1, so we get a 1 here. 2 to the power of 1 is 2. 2 to the power of 2 is 4. So you see what's happening? 1, you double that, 2, double that, 4, double 8, double 16, 32, 64, 128. How do we know when to stop? Well, the number we're looking at is 78. So you keep going until you just go one above. So 64 was still lower than 78, so we go one more. That's 128. When we double 64, we get 128, and now we stop because we're already over this decimal number. All right? Okay. The next thing is, we now need to see out of these, there we go. Out of all of these, so think of them as a bucket which has a bunch of different blocks. One block has 128 written on it. Another block has 64. Another block has 32, and so on. So think of each of these as a block with a certain number on it. And our job is to pick those blocks which will add up to this number. So as you can see, if you take 64, and then you take a block that says 8, and you take a block that says 4, and says 2, if you take all of these, they will all add up to 78. Now, that's well and good if it's a small number like 78. You can kind of guess which blocks to pick to make that number, but that's going to be really hard if it was a large number. So the good news is that how you pick these blocks are based on a certain method or technique. So let me explain that technique. And once you follow that, it doesn't matter how large or small the number is, you'll be able to figure out which ones you need to pick. So let's see what that method is. So once you have indicated powers of 2, so we have 1 and keep doubling, 2, 4, 8, 16, 32, 64, and 28. What you do is you pick the block which is either just below this number or equal to. So either just below or equal. So when we look at this, it's too high. 128 is too high. You can't pick 128. So you ignore that. Next you look at 64. 64 is lower than 78. So yes, you can pick it. How do you indicate you're picking that block? You put a 1 here. So 64, I picked that, so I put a 1. So what's left over now? We were trying to make 78. We've already picked 64. So 78 minus 64 is 14. We still need to pick enough to make 14. Now take 14 and follow the same rule. We can only pick just below or equal. So when we go to the next number, 32, it's too high. We can't pick that. Compared to 14, that's too high. So ignore. When we ignore, we put a 0. We look at the next one, 16. We want 14, so it's too high as well. We need to ignore. So we put a 0. Number 8. Now 8 we can pick because it's lower than 14. So we pick it. When we pick it, we put a 1. Now what's happened? We were trying to make 14. We've picked another 8. So the difference is 6. We still need to pick enough to make 6. Go to the next number. Can we pick 4? Yes, because it's lower than 6. So we pick it and we put a 1 here. So out of the 6, we've now used up another 4, which means we're left with 2. We look at the next number. We can only pick lower or equal. In this case, 2 and 2 are equal. So yes, we can pick that. When we pick it, we put a number 1. So what's the difference now? 2 minus 2, which is 0. So we don't need any more blocks. When this reaches 0, we've met all the conditions. So we don't need to pick this last one, so we put a 0. All right. So now if you look at it, it's given us a series of 1s and 0s. 1 if we're picking that number, 0 if we're not picking that number. So if you want to double check, you're going to say 64 plus 8 plus 4 plus 2 will give you 78. In other words, if we pick a block that says 64 and then one that says 8, one that says 4, and one that says 2, then we will get a total of 78. So that gives us a series of 0s and 1s, which is the binary number that we've gotten based on decimal 78. So decimal 78 converted to this series of 0s and 1s. So you literally copy each of these exactly as is. So 1, 0, 0, 1, 1, 1, 0. That's our binary number. See that? Okay. When we do a lot of, I'll give you some practice questions and then you'll be able to apply it more quickly. So just try to understand this for now and we'll do practice after. Let's do the reverse. So let's say, how do we convert binary to decimal? So let's take this binary number. It can be any binary number. So the first step is you write this binary number kind of spaced out. So 1, 0, 1, 0, 0, 1, 0, 0. That's what we have here. So I just spaced it out and wrote it. What was the next step? Well, the next step is we're going to take a power of 2 because we're dealing with binary and write that power of 2 on top of each digit. And we begin from the right by saying 2 to the power of 0. And then we keep increasing it as we go, all the way to the last digit. And then we write the answer. So 2 to the power of 0, anything to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, and so on. So really we're saying 1, double, 2, 4, 8, 16, 32, 64, and 128. The next step is whenever you have a 1, that one you're going to use. So you're saying 128 I'm going to use. I'm going to add that up. That's a 0 we ignore. 32 I'm going to use. So I'm going to add that up. Ignore. Ignore. 4 again we have a 1 so we're going to use that. Ignore. Ignore. So what do? We add up all of these. So 128 plus 32 plus 4 gives us 164. What have we done here? We've taken a binary number, which we wrote down here, and we converted that into a decimal. So this number in binary makes 164 in decimal. So we've done the reverse of this. Here we took a decimal number 78 and made it into binary. Here we're taking a binary number and making it into a decimal. Okay? Now comes the fun part, because this is the part we're going to use in understanding permissions later on. And it's actually quite easy. Once you understand binary, then octal and hex are really easy if you use this method. So binary and octal, the relationship is 1 to 3. So a group of three binary numbers makes one octal number. So let's see how we can use that. So we're given this binary number. So step 1, you write it out, spaced out. But instead of just evenly spacing them out, like we did here, I want you to group it into threes, beginning from the right. So you're going to put 0, 0, and 0. This group of 3 zeros comes together here. Leave some space or draw a line, whatever you find convenient. Then you take the next. So that's 0, 1, 1 becomes 0, 1, 1 is the next group of 3. And then finally these last three ones. So 1, 1, 1. So what you're doing is you're taking the binary number, beginning from the right and kind of splitting it into group of 3. Another group of 3, another group of 3. All right? For each of those digits, again, these are binary. So we go 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. Now the important thing here that's different from what we were doing before is we're going to stop at this point and start with 2 to the 0 again. 1 and 2. Stop here again, 2 to the 0, 1 and 2. Whereas previously we kept on going. We kept on going 2 to the power of 0, 1, 2, and we kept increasing it all the way. That's how you do decimal, binary to decimal. But if we want to do binary to octal, we've got to start from the right, but don't keep going. When you're putting powers of 2, you go 1, 2, and 3, and you stop. So in other words, power of 0, power of 1, power of 2, and then stop. Start again. 2 to the 0, 2 to the 1, 2 to the 2, stop, and same thing. And then, of course, by now you know that you put the answer here. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. Stop. Start again. 2 to the 0 is 1. Double it 2. Double it 4. Stop. 1, 2, 4. So from now on, once you understand this, I'm going to eliminate this step where we actually put powers of 2, because you should remember now that when you're dealing with binary and octal, you simply go 1, 2, 4, stop. 1, 2, 4, stop. 1, 2, 4. All right? The next step is we are going to see which of these digits we're going to use. So if there's a 0, when you multiply 1 with a 0, 2 with a 0, 4, everything stays 0. So your answer becomes 0. But in something like this, we've got a 1 and a 1 here. So you ignore when there's a 0, because 1 multiplied by 0 gives you 0. But 1 multiplied by 2, so 1 multiplied by 2 gives you a 2. So in other words, you're picking that number. Pick the 2. 4 multiplied by 1, you're picking the 4. And then within this group, you're going to add. So 4 plus 2 is 6. So out of this group, we were getting a 6. Look over here. We're going to pick the 1 because we're picking this, picking this, picking this. So 4, 2, 1, all of these we need to pick. And then within the group, we need to add. So 4 plus 2 plus 1, which gives us a 7. So from this binary number, by beginning from the right and grouping it into a group of 3, a group of 3, and a group of 3, and then within each group, finding out what octal number it translates into by ignoring when it's a 0 and picking the number when it's 1, and then adding only within a group. So this group gave you an answer of 0 because none of them were 1. This group gave an answer of 6 because we had a 4 plus 2. And this group gave us a 7 because there was a 1 plus 2 plus 4. We have to pick all of them. So the answer is 760. So in the final result here, you don't add them up. When you're doing binary to octal, you simply write down 7, 6, and 0, and that's your octal number. Okay? If you were doing the reverse, so octal to binary, so we're given, let's say, we're going to use the same number. So let's say we were given octal number 760. How do we make a binary from it? Well, you write down 760, which is whatever octal number you're given, space it out. Now for each of these octal digits, you have to come up with what 3 binary digits are making up that one octal digit. So we're doing the reverse here. So the simplest way that you can do this is underneath each digit, write down the powers of 2. You need 3 of them, just like we did here. So I'm going to eliminate this step. So we're just writing 1, 2, and 4, stop. For this next digit, again, write down 1, 2, and 4, stop. And the last digit, again, write down 1, 2, and 4, stop. And what you need to think here is, which of these numbers do you need to make this number? Well, it's a 0, so I don't need 4, I don't need 2, and I don't need 1. When you don't need a number, you put a 0. So I put zeros underneath each of these. So this octal number is giving you 000 as the binary. Then we come to 6. Again, we had 1, 2, and 4. So which of these do we need in order to make the 6? Well, we can take the 4 and the 2, and that'll give us a 6. So we don't need the 1 now. So we put a 1 here, we need that. We put a 1 here, we need that. We put a 0 here, we don't need that. So the number 6 octal is converting into 110 as the binary. See that? And number 7, again, 1, 2, and 4. We need the 4, and we need the 2, and we need the 1, because then only when we pick all 3, that's how we will get a 7. So the octal number 7 converts to 111 in binary. So really, you see what we're doing is we're taking each octal digit and kind of opening it up into a group of 3 binary digits. Now, some people like to just memorize what 7 means, what 6 means, and so on, and just put that. That's okay, but if you do this method, you don't need to memorize anything. So that's the one I'm teaching you. I find it simpler. So octal digits, and for each octal digit, open it into 3 binary digits. And then you just simply write all of these together. So when you write them, you get 11111 0000. That's your binary. So we've taken 760 octal, and that converts into this number in binary. So you see, we kind of did the reverse. We took the binary that made 760 octal. We took 760 octal, and that made this binary. So you know how to do it both ways. So this is the most important of the numbering conversions that you need to focus on for the purpose of this course. But just to finish it off, I'm going to also do the hex conversion, and it's really simple once you understand binary. So again, we'll take the same binary number, and let's see how we convert this into hex. So the relationship between binary and hex is 1:4. So for each hex number, it opens into 4 binary digits. So let's take the binary number and write it out, but this time we have to group it in 4s. The important thing is you have to group beginning from the right, otherwise you will get the wrong number. So we wrote the binary number out, and we began from the right, and then said 1, 2, 3, 4. So those 4 zeros and then stop. The next 4 ones and stop. And then we just had 1 left here, right? So I put 1, but to make it a group of 4, I just added zeros in the beginning. That does not change the value, it just kind of reminds you that you're dealing with groups of 4. On top of each of the digits, you go powers of 2, and now we know that the powers of 2 will be 1, double 2, double 4, then double 8. So 1, 2, 4, and 8. In hex, we go 1, 2, 4, and 8, 1, 2, 4, and 8. Once again, just as we did here, if it's a 0, we're going to ignore it. So this results in a 0. If there's a 1, we need to use that number. So we have all 1s here. That means we need to use 8 and 4 and 2 and 1 and add them all up. So you add only within a group. So 8 plus 4 plus 2 plus 1 gives us the number 15. But in hex, remember, you can only use 0 through 9, and then you have to use A, B, C, D, E, F. So 15 really means an F. So change your 15 to an F. Here we just have 1 because these are all zeros. So what is the final answer? It's a 1, F, and 0. And that becomes our hex number. You see how easy that was? And to do the reverse, so let's say we're given a hex number. What is the binary? Write down your hex number, spaced out. Make sure if there's a letter, you convert that to the corresponding number. So if this was A, this would be converting to 10. But since it's F, it's converting to 15. And then you need to open up each of these digits into 4 binary digits. So for 0, again, you have to write 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. Which one of these do we need to use to make a 0? None of them. So we put zeros for each of them. Which of these do we need to use to make a 15? Well, we need all of them. 8 plus 4 plus 2 plus 1, then we'll get a 15. So when we use that number, we put a 1 under it. So we have 4 1s here. So 15 is actually 4 1s. 15, which is really an F in hex. Here, we need to make up the number 1. So we just need to use this one. So we put a 1 here. We don't need any of these. So we put zeros here. And again, we simply copy these numbers all the way, and that gives us this binary. Now, when there's zeros on the leftmost side, those can be truncated. It does not change the value. So this in binary is same as this. So all we did was took out these first 3 zeros. So you can see that once we understand binary, we have converted from binary to hex, from hex to binary. What is the relationship between hex and binary? One hex digit is 4 binary digits. With octal, the relationship of octal, one octal digit is 3 binary digits. So we took the binary and made it into octal. Here we took the octal and made it into binary. And before that, we had looked at decimal and binary to decimal. So now hopefully you understand the numbering systems, and we're going to, in the next video, look at how binary and octal relate directly to permissions in Linux. Permissions meaning what can we do with this file? What can we do with this directory? Are we permitted to look at the contents? Are we not permitted? So how we control the permissions is based on understanding binary and octal, and that would be the topic for the next video. Thank you.